everybody. Just doing a quick sound check because my voice is quite low on this one. Testing, 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 testing. All right, so hello, welcome. Firstly, let me just apologize for sitting down today. I forgot my little camera, so it's a bit complicated, but this laptop camera is quite tight on my face, so I can't kind of stand up and wave around as much as I'm used to. So I don't really like sitting when we chat, but here we are. Now, how is everyone, by the way? Well, yeah, how's iteration 3? Yeah, I have some mixed reactions from people is how I would describe that response. I imagine that it's quite stressful for some people. I imagine that other groups are going pretty well with it. Regardless, I hope you're okay. Is everyone excited for a bonus lecture? Yeah? Is anyone here, they don't want to watch the bonus lecture, they're just here because they just come to lectures? Is anyone in that boat? Okay, some people. That's good. Well, I'll just get straight into it. Just beforehand, let me preface. We were going to do a 2-hour lecture today, but what I decided to do instead was to do a 1-hour lecture today and then a 1-hour lecture online on Wednesday. And what we're going to do on Wednesday is basically a follow-on from today based on what people like from today. So what I mean by that is we're going to do some stuff today in the bonus lecture. Then I'm going to post on the forum or get Lecture1 to post on the forum like a bit of a, if that was interesting, what more do you want to learn about? You know, we have another hour on Wednesday and you can just reply to that and then we'll go through that on Wednesday. But otherwise, let's just kind of get into it. So, today's bonus lecture has no slides because what we are going to be talking about is front-end programming. Now, it's important to note that I have an entire course dedicated to this. It's called COMP1531. It's one of the bigger electives in CSE. It's an elective, not a core course. And I started it up in 2020 as a way to try and give students exposure to front end. We spent an entire 2-hour lecture in that course in the first lecture talking about the history of websites and why they're important and all this kind of stuff. I don't really want to kind of drown you in that today. What I would rather do is just give a quick summary, which is that there's technologies that we use these days to build websites, just like this website here, the course website. And there's a lot to that, but they're all based on some fundamental technologies. And we're going to be talking about the fundamental technologies today and just learning a little bit about it. The reason that you should care generally about web front end is because everything these days nearly is web front end. And even applications that don't feel like they're web-based are web-based. So Microsoft Teams, VS Code. Did you know they're actually just web browsers in disguise? Right? They feel like apps a lot of the time, but they're actually based off the same kind of core technology that every other website's based on. So most of the time, nearly everything you're interacting with on your laptop in particular gets a bit more complicated with phones, but it's still of a similar degree of, technology. Everything you do on your laptop nowadays, besides some fundamental applications like Finder or Windows Explorer, is like web-based. It's everywhere. So if you're going to be building an interface for people, 99% of people are building it either as a mobile app or a website. And whilst those two technologies do differ, in some semi-degree, understanding at least one of them is exceptionally powerful. And the cool thing about web is that, you can still go on websites on your phone, right? Like you just go open up Chrome and you go to a website. So the technology used to build this site is far more in depth than I think is okay in an hour or two. I do see things like people be like a 1-hour crash course in like this really advanced technology with web, but I don't think anyone's really going to understand it in 60 minutes, so I don't really like to do that. So we're going to focus on basics today because they're so pivotal to understand the more advanced stuff. So the best way to understand a web browser is that a web browser is a compiler, right? It compiles code, and what it does is instead of producing a binary, it produces a rendered web page, is how to think about it. So you write some C code or some whatever JavaScript code, it gets run through a program like GCC, DCC, Node, and then something gets outputted, typically a binary, or in the case of Node, obviously it produces some kind of byte code and then runs it straight away, right? It does that compilation in real time. A web browser takes code and outputs a web page. Now, there are 3 key technologies that a web browser compiles, basically. And I'm simplifying a lot of things here, so it's quite concise. There's HTML, there's CSS, and there's JavaScript. JavaScript's a really interesting one. HTML stands for Hypertext Markup Language. CSS stands for Cascading Style Sheets. And JavaScript stands for trauma. No, just kidding. It's just JavaScript. It's just a language. Now, HTML, CSS, the browser understands these 3 things by itself. Chrome on your computer, you don't need a compiler, you don't need a program. It's one of the coolest things about front-end is you don't actually need to install anything to write code. All of you can write code for a web browser just on the basis that you have Chrome or Safari installed on your computer. Now, what I'm going to do here is I'm going to go make my web page. And most web pages, where is it? It's front-end. Front-end, I'm going to call it page.html. Most kind of basic pages on the internet might be a .html file, right? And what I can do is I can write the word hi here. And on my right-hand side, I have a web page. I'm going to go open up this. I'm going to go into front end, and I'm going to go and drop that there. Now, this on the left is literally some HTML file. On the right, it's a web page. The browser is loading up that web page. You don't need it to be on the internet. Whilst you can actually just use the files locally. But you can see in that case that it's my web page. Now, here's the interesting thing. Let's go and add some really straightforward HTML to that page. I'm going to go add this little B tags. Anyone seen those kinds of things before? At least seen them around. I'm sure many of you have seen little bits of HTML. What that does is that makes the things between those tags be bold. I'm sure it's not totally rocket science. And you'll see that the text suddenly on the web page got really bold. If I undo that, it's not bold. If I add that in, it's bold. Cool. Now, back to what I said about compilers. If I open up the original source code of that web page here, I see this. So how a browser is actually working is that a browser receives this information. That's what I wrote in the file. That's my source code. And it outputs that on the right-hand side. It's essentially compiled the HTML and rendered that on the right-hand side. So if we can establish our source code to output understanding, that's a really important first step. And then everything else with web is just doing more codey stuff to make more visual stuff happen on the right-hand side. Now, the thing with HTML and CSS is that HTML generally concerns itself with the structure of web pages. It has a lot of really basic tags. Like it can make things bold. It can make things italics, like that. You can add a big header called H1, which is the biggest header, like that. There's a big header. You can add a smaller header, which is a slight, a different size header. You can go and make an unordered list of items where I go and say, you know what, I need to list a few items like this. UL stands for unordered list. LI stands for list item. I can go and make a hyperlink if I want to link someone to Google. I can do this, which basically says I want a link, and the text of that link is Google, and its hyperlink reference where it goes to is Google, where if I click on that, it takes me to google.com. I can go and grab this image off Google, like this, copy image address, right? Has anyone ever done that when you want to link to an image? You right-click and you grab the URL, I can do that, and then I can also include that image on my page by saying I would like an image that the source of that image is this. That's not what I wanted. Go back a page. Right? So I can also add a line break if I want some space between things. Add a few of those like this. So there are these really fundamental structural elements of a page that are concerned with images, links, titles, dot points, bolds, paragraphs. I always like to describe it as it's the Wikipedia code. I use Wikipedia a lot in my examples. We're going to random article it today. Who loves Wikipedia's random article? No one? Okay. Where is random article? What is it today? James Stanley, the 10th Earl of Derby. Oh my God, these are never interesting. I use Wikipedia as an example because Wikipedia is such a simple website that the vast majority of it you could do with really basic HTML. You know, it's like a header, a line, some text, some hyperlinks, you know. It's a really uncomplicated type of page. And, you know, it reflects that. But that's HTML. It provides the core structure. That's also why our web page itself is a .html file. Where things can get a little bit more fun is when we introduce CSS. CSS was a technology introduced a few years after HTML that was basically built on top of HTML that allowed you to have really fine detail control over the aesthetic, layout, visual elements of things. And what I mean by that is that, you know, the original HTML standard, it could do things like change the font family or the color and stuff, right? Like you could say here, color equals red. You could do a few things like this. That doesn't even work anymore, maybe. Maybe it doesn't. Or you could say like, you'd do things like if you want it to be even bigger, you'd say like big, like that. You'd make it bigger and bigger and bigger. CSS came and said, you know what? The original HTML stuff, it's not detailed enough. It's very like brash, you know? You can do a few, bigger, blue, like a few things. But we want to make it super fine-tuned. So what they did was they said, you can go and write some code in between two style tags, because this is an HTML tag here, right? Style. And all the code I write inside of here is now CSS. This is all CSS in here. So there's a little CSS language part of my web page. And the most basic usage of CSS is that what you'll typically say is something like this. You'll say header, and then I'll say font size 200%. And then what I do is I say ID equals header. So there's a really simple relationship with CSS and HTML where you can take HTML elements, give them a unique name, such as header. I could call this anything I want. I could call it apple, mango, banana. Doesn't really matter. And what it does is it applies these particular visual rules to that element. So CSS kind of applies, you know, the artisticness to a lot of the web page, such that when I reload this, the header is going to be, unless I did it wrong. Why is it not that big? Oh, OK. It's already 200%. I could make it 500%. I could make it really big. I could change its font family to Arial if I don't like those little twiggly things. I could change its color to blue if I wanted to. I could make it underline as well. I could change the font. I think it's text spacing. Is it text spacing? Font spacing. Let me just try and remember. Font spacing, CSS. Letter spacing. That's what I'm looking for. I can change the letter spacing so everything's kind of... I should actually read about that one. Oh, it has to be pixels. OK. 10 pixels. You know, make it a little bit bigger. -5 pixels. So make it all kind of collapse down on itself a little bit if I want a bit of like a stylized header. You know, like there's a lot of control there. Like the list of these properties is quite lengthy. And the cool thing about CSS as a language, because all of this here is CSS, it's remarkably straightforward for 90% of it. It's like you specify the name of something that you want to apply properties to, and then you just give it a fat list of properties. And that list, there's like 100 different properties you could apply. You know, tons of stuff like italics, bold, margins, paddings, lots of things. If I wanted that to be a little bit more to the right, I could give it like a 10 pixel margin to the left. I could give it a border if I wanted to, like a light gray border. I could give it a shadow, and I want that shadow to be, I think it's like 5 pixels to the right, 5 pixels down, the shadow to be spread across 10 pixels, and I want it to be a really light shadow, like that, you know. Now, naturally, like a lot of these properties, I've been working with this stuff for like several dozen, like not several dozen, but several to a dozen years. Like I know a lot of these things, but there's many like you just saw with letter spacing where I'm like, I don't remember what that was, so I just Google it, you know. It's a pretty common thing. I like want something to look a certain way, I'll go and Google it. And now we have this really ugly looking thing that I created, which is this kind of funny looking header. And that's CSS, and everything kind of exists in this little style tag. So the whole page is HTML, but there's a CSS section, and it applies to tags. So the CSS structure is so simple. Property, value, property, value, property, value, property, value, just goes on and on. There's just many, many more properties. And you can see it as I start typing it. These are like all the different things that just have, like, this is just some of them. Translate, God knows what. And there's really crazy ones you can do, like all the new stuff. Yeah, like this is all doable now. Whee, that looks fun. It's a lot more complicated, some of this stuff, though. But just a quick taste of it. This stuff's really simple. It's basically saying, hey, what I would like you to do is I'd like you to animate the header here. Let me get rid of that. So I could say here, I want to create a animation. Keyframes is like when you animate something, if I call that example, I'll do that myself. And I'll say at 0%, I want your color to be blue. 0% means at the start of the animation. And then at 100%, I want your color to be red. And what you basically are saying to CSS is, here's two endpoints, right? At one end it's blue, on one end it's red, and I want you to animate between them, and it'll figure out how to do that. And what I could do there is then say, actually, I want you to animate this. Animation name is example, and the duration over what I want you to do is going to be 5 or 10 seconds, like this, right? So again, this is some more complicated stuff, but if I refresh this page, you see how it's like over a 10-second period, moving from its starting point here, blue, all the way to red. And then I don't know if it goes back. I probably would need, yeah, it just keeps looping forever. And I could speed that up if I wanted to. I could make it 1 second, you know, so it'll just like over, oh, yeah, it's just stopped now. OK. But there's lots more properties, I'm sure, like to do with animation, iteration count. I imagine that's like how many times to animate it. That'll probably do it 5 times, you know, and then stop. Cool. I wonder if we can go even faster. There you go. So you could make all kinds of crazy things if you wanted to. There's my little like aggressively animated item. If I wanted to add some more stuff to it, where it doesn't just go from blue to red, I could add more keyframes here, and I could actually make it move to white. So say I want you to start from blue, 0%, go to white in the middle, and then red at the end, and now it's going to be a funny little header that looks like it kind of like blends out and then back in as red. You know, like it's limitless, right? But it's very fiddly. It's like it's very simple stuff that you can do a lot with. But that's CSS. And the structure of it, I think you kind of get. You can just add more and more of these things. Like if I wanted to style this piece of text up here to be something else, I could give it an ID of, you know, potato. And then here just go potato, color yellow. You know, I could do lots of stuff. That's beautiful. We've really created art here today, everyone. So that's CSS in a nutshell. HTML structure, I kind of glossed over that, but it's actually also really straightforward if you hadn't figured it out. A lot of HTML consists of open tags and closed tags. They all kind of look the same. And then most tags are able to take in what we call like attribute value pairs, where a tag like h1 can take in this little ID equals something. Or in this case here, this Google one takes in a little href thing. Every tag can take in multiple attribute value pairs, anything that's valid. So for instance, with hyperlinks, you notice when I click on Google here, it just takes me to that page. But if I add in another line here that says target equals underscore blank, that's actually an instruction to the web browser to open it in a new tab. So you notice when I click on that, it opens it in a new tab. So you can add multiple of these like href and like target, these attribute value pairs to every tag. But again, that's the cool thing. HTML is really simple. It's just tags of different types with different attribute value pairs. And this is like, really, that's kind of it. That's like the foundations of how most web pages look, how they look a certain way. HTML and CSS are very straightforward little languages. Is there any questions about that before I kind of go on to JavaScript? You're just thinking about iteration 3. JavaScript was also added to browsers around the same time CSS was. And the purpose of JavaScript was generally to add a level of dynamism to the page. And I don't mean dynamism like the little header that flashes red 100 times. I'm talking about the dynamism that allows you to do anything more than just make a page look pretty. So if you've ever been on Instagram again and you're sending messages on Instagram, or you're hitting like on a post, or you're hitting comment, or you're on a website like the 1531 website, and you click here and like that pops out, and you expand and retract some of these things, or you go to the lecture page, and what's a better page, like the runs page here, you know, and things are loading, and then you've got your little thing up the top. I don't think tutors have that, only you have it, where you can submit stuff. Like all of that gives a page a bit more dynamic life is all JavaScript, because HTML and CSS themselves are quite static. And what I mean by that is, let's imagine that we wanted to create two little buttons, a plus and a minus button. And when I press the minus button, I want a number to go down in value. And when I press the plus button, I want the number to go up in value. So I could go and use HTML to make a couple of buttons. I could make a button that has a minus in it, and then I could make a button that has a plus in it, like this. And they would just exist on my page. Cool. I could make a little line break there. And then what I could do is I could add a really big piece of text here that's like a number, the number 0. Okay, so whenever I click that button, I want the number to get bigger, and whenever I click that button, I want the number to get smaller. But right now, nothing happens. I can make the button look really pretty with CSS. I could make it rainbow. Let's do that. I like colorful things. You know, let's say actually, this is another thing you can do is, actually I won't go, yeah. You'll see here that I used this thing called ID before to look up a particular style from CSS. The other thing you can do is, instead of adding an ID, you can do this thing called, what was I doing? Wanted that. You can add a class to a button, or other stuff is that I don't actually need to do that. I can actually just say button. I want to style all the buttons on the web page to be a certain thing. Where here I could say, you know, background is blue, like that. I don't need to like give it an ID, but I could. They're terrible buttons. But let's make a really pretty one. I'm going to go color picker into Google, and I want to have a really pretty color that goes from like a, I don't know, what's your favorite color? What's your favorite color? Yellow? Cool. What's your favorite color? Green. Okay. So I want to have a really nice little button that goes from like a soft yellow here. So I can go find that yellow, and I can go copy its hex code. Hex code's a hexadecimal representation of colors. And I could say I want my background to be a linear gradient, which just means like I want you to move between two colors from yellow to green. You find a nice, not too threatening looking green. That one. From these two colors, and then that can be my new button background. So now I have some really pretty buttons. And then I can give my buttons more padding on the inside. I want them to have 10 pixels of padding around them. And in fact, I actually want to give them a lot of padding, a lot more padding on the left and right. So I want to just give them a little bit of padding on the top and bottom, but a lot of padding on the left and right. That's probably too much padding, so I'm going to make it a little bit smaller. That looks kind of cool, but now the little buttons are a bit small, so I'll make the font size a bit bigger, maybe 200%. And now I have these two cool buttons. Now, one thing that I've done here, which is a bit silly, is that because I've overridden the background, when I'm clicking on these things, you can't tell I'm clicking on it. It doesn't look like I'm clicking on it, you know? It just kind of looks like it's sitting there, like a bit of a painting. So what I can also do is I can say, you know what, when someone hovers over a button, what I would like to do is, this will be a really easy hack. I just like to make it half transparent. Oh, not hover, I meant active. Is it active? Yeah. So now when I'm clicking on it, the button becomes active when you're clicking on it, and it's kind of like changing color a little bit. That just helps people, you know, visually see that. You wouldn't normally make something half transparent, though, to make it visible. But that's, again, all CSS. I can't use CSS to make the number change. This is where I have to use JavaScript. And to use JavaScript, what I then add to my page, and I can just add it here, is instead of style, I add script. Script is like style, but for JavaScript, where I can go and write things that you're probably a little bit more comfortable with, like console.log. And when I load this page now, you'll see there's no hello written on the page, because where it's actually gone to is the console in the web browser, because the web browser has a console, just like everything else. What you see on the web page is not what is console logged, it's like what is rendered. The console log actually goes to a console. So if I was to say, hello, what's 2 plus 3, like this, I get hello 5, right? Like it's all as if you're using it on the terminal here. But where JavaScript can be a little bit more fun is that I can do some things, and do some things by changing the page. And a lot of JavaScript with the web browser focuses on reading information from the web page and changing information from the web page, or like listening for actions. So one of the most common things you can do is you can write this little bit of code. It's a big piece of code but we'll unpack it in a second. Right? And what I have to do is I have to go give an ID to this button called plus. And this little piece of JavaScript, what it does, it's very hard to understand sometimes, is that document here refers to the entire web page. Just refers to the website. I'm saying, hey, can you go get the document, the entire website? Can you then please go and find me a particular HTML element with an ID called plus, which is this one up here. So the JavaScript goes and finds that particular HTML tag. And then it says, OK, now that you've found that tag, can you please listen very carefully in case someone clicks on it? And if you detect someone to click on that element, I would like you to call this particular function here. That's just us doing the whole first class function thing. So this is just a function to call when it's clicked. And I've just written it in like that. And what that function is going to do when it's clicked is it's going to console log plus. So you'll see here, what have I done wrong? Get element is not a function. Add, have I written that wrong? Add eventer listener. I'll click this, and you see how every time I click it, it does the plus thing. You'll see it's not repeating itself. That little number's next to it's changing. That's just to save console space. But like every time I click it, something is happening. And I could go do the exact same thing for a minus button as well. I could say, yep, every time someone clicks this minus button, ID equals minus, I want you to console log something different. Plus, plus, minus, plus, plus, minus, plus. OK, so I'm using JavaScript to detect and listen for actions. That's one big useful thing it does. But the other thing it can do is it can dynamically update content on the web page. So what I'm going to say is that, and I'll just use the plus one for now, hey, when someone clicks on it, I don't want you to just console log plus. I would actually like you to change this 0 to a 1. And the way you do that typically is you say document.getElement by ID number dot inner HTML, inner text equals 1. So let's imagine I give this an ID of number. This only works if you give things IDs, right? Because JavaScript needs to know where to find something. So that particular piece of text with the 0 in it now has an ID of number. And I'm saying to JavaScript, hey, can you go find the web page, then find the element called number, and then I want you to set the text inside of it, because see how the 0 is kind of inside of it right now. I want you to change that to a 1. And you'll see that when I do this and I click plus, it changes to a 1. However, that's not what we want it to do, is it? Because that's just going to set it to 1 forever. So what we need to do instead is to increase that number by 1. Well, one way we can do that, no pun intended, is to simply say, let's get the previous number, which is just going to be the inner text of it currently. So this is the current text of the item, and I would just like to capture that. And then I'm simply going to say, well, the new number should be previous number plus 1. Right? So I go find what's currently inside that tag, and then I increment it by 1, and then I set it to be that new number. So now when I click plus, what's happening here? Well, we're playing around with JavaScript types here. Because think about how JavaScript works. What we are doing here, when we capture this, even though it's a 0, it's still the character 0, right? Because everything on a web page is a string, basically. Like we know intuitively that it's an integer, but it's actually a string. So when I capture this, this here is going to be a string. And then what happens is when you try and add a number to a string, what JavaScript will do typically is it will turn the number into a string. It'll promote the 1 from here. It'll basically be the equivalent of this. And now it's string concatenation. We're joining stuff together. So instead, I kind of need to do something like say, well, I need to parse int. I need to turn that string into a number there. And then I'll see if this one works. And now it's increasing every time I click it. OK, then you could go do the exact same thing down here. Instead of saying minus, I could do the copy and paste that and just change that to a minus. And now we've got this cute little web page where everything just kind of works. Right? We're increasing, we're decreasing, lots of stuff like that. And again, the purpose of showing you that is to say that, hey, that is essentially what JavaScript allows us to do. It allows us to add life to the page, right? Life in terms of actions. Because all JavaScript really does at a core is it listens for particular actions to occur or waits for particular moments in time. And then it does some processing and then updates what's on the web page. That's it. And if you think about every website you see, it's some variant of that. You think about Instagram, right? You get to the bottom of your feed and it loads some more stuff. Well, what's happening is it's waiting until you scroll all the way to the bottom, and then it is JavaScripting itself, and it's talking to the Instagram server, and then pulling information back, and then generating new content on the page for you, right? Like, that's all JavaScript. But again, there's a tricky thing about this is these aren't three separate languages. Oh, sorry, they are three separate languages, but they're not totally independent. They all kind of rely on each other, you know, because JavaScript and CSS are built on top of HTML. However, so they can't really exist without HTML, but also a website that doesn't use JavaScript is like a lifeless web page that does nothing, and a website that doesn't use CSS is probably the ugliest thing you've ever seen, you know? So they all kind of coexist really, really nicely together. And you can do a whole of a lot more stuff with it as well. But yes, so I could do a bunch more examples for the next 15 minutes, but just so we don't run out of time for questions. Are there any questions about this so far? Yep.
Just, you mentioned that we could use class instead of ID. So
yep.
What's the difference between the two? Like, why would you use one or the other?
Yeah, so class and ID, like I could replace this potato here. If I replace that, let me just get them on the same screen. If I replace that hash with a dot, I can replace this potato here with class, and it has the same effect. Classes are generally, based on the HTML standard, it says that an ID should only be used when there's only one instance of that type. So classes and IDs are just two ways of doing the exact same thing, but you would use a class if you have multiple of these elements on the page and not just one. Pretty minor thing. Yep.
How would like automatic website builders like Squarespace and like Bootstrap Studio work under the hood?
How do things like Squarespace and Wix and stuff work under the hood? I mean, basically, they've just built some web pages that allow you to, you know, configure things. And what that does is itself, it just goes and like shoves a whole bunch of pre-written stuff together onto an actual website for you. You know, so imagine it's like they've kind of got this big templated series of things where they've got their own header bars and their own sign-up forms, and they're just slapping them all together. The cool thing about things like Squarespace and Wix is that they've essentially eradicated a market that existed 15 years ago, which was like, I need a website for my business. So like you go back and like a hairdresser that just needs like something to show some pictures of pretty haircuts and maybe a booking thing. Squarespace and Wix have just like meant 90% of websites on the internet by volume are just that. And that's a great thing. But anything that isn't cookie cutter, it can't do, or if it tries to do it, it's really like sluggish and slow, because it's often like any system that's like build your own, it's like super bloated because it's like running tons and tons of stuff. So like the website we build for work, it's definitely not based on Wix and things because we have really specific needs. But yeah, for Squarespace and Wix, they figured out most people are doing the same few dozen things. Yeah, cool. So what I'd like to do, because again, I will make that forum post where we can let you all suggest some stuff. But what I actually want to do is really talk about JavaScript for a second, because it goes a little bit unnoticed. And it's really confusing, actually. I think it's one of those things that is like even more confusing when you think about it a little bit, and then it makes more sense. But when it comes to JavaScript, JavaScript was actually born in the web browser in the 90s sometime, like mid-90s. It was invented for use in Safari and Chrome and all those kinds of things. What happened about 10, 15 years ago was some people said, hey, we like this language. Wouldn't it be cool if we didn't just have the web browser be the compiler for JavaScript? What happens if we actually built a command line compiler that can run code on a terminal? And that's where Node.js was born. So the Node.js you've been using in the course, funnily enough, is actually a newer thing in the world of JavaScript. And they're two fairly different worlds, where one world over here is running in a web browser, the other world it's running on a terminal. So Node.js in a terminal, sometimes we refer to it as web JavaScript in the browser. And what's really tricky about those two things is they're kind of similar, but they're kind of different. And you probably noticed that with the code, right? like all this nonsense here, that doesn't really feel comfortable to a lot of you, does it? Like it looks like totally random stuff. You haven't seen it before. But then at the same time, you probably see things like const something equals and parseInt, and you think like, oh, I've seen that before, you know, in your project. And the reason for that is that to understand JavaScript, you have to imagine that it's basically like a core language, and then there's like an implementation of it for terminal and an implementation of it for web that has some extra stuff that is specific to those two things. And what I mean by that is, you know, all Java, whether it's, you could write JavaScript in the web browser or in Node.js, and really basic stuff would run, like const A equals 1, const B equals A plus 2, console.log B, you know, function hello, return, like, you know what I mean? Like I'm just writing some pretty random stuff. But this code here, it would run in a web browser, fine. It would run on the terminal, fine. It's like the common part of JavaScript. Then what happens is it forks off a little bit. There's stuff in JavaScript, in Node, that doesn't exist in the web browser. Things like process.argv, you can actually capture argvs and things in Node. There's things like importing, import, you know, fs from fs. The entire file system library itself is specific to Node.js. If I try to write, say, you know, import fs from fs in here, like imagine I just wrote it up the top here, you'll see how the browser deals with it. The browser's just like, cannot use import statement outside of a module. It's, yeah, I mean, that one, they're getting a little bit better at it now, but it's like, they're like, what the hell is that, basically? There's no NPM or anything like that, you know? Like, in a way, the browser JavaScript's a lot more basic because it just kind of is like simple JavaScript. But at the same time, what's really interesting is in the web, if I say console log document, and I load that up, you'll see that I get this massive object here that is basically the HTML page. But if I was to say open a terminal and make a file, like here file.js, and I was to write console.log document, what's going to happen now when I run that is it's just going to say document is not defined, you know? But similarly in Node, if I say I want to console log process, that works because process is like a global variable in Node land. Whereas if I tried to console log process here with, actually that one might work. No, it doesn't. That's just, I thought it might work because my editor kind of picked up on it. See, I was like, oh. But that's because my editor doesn't know whether I'm writing this JavaScript for the web or for Node, you know? So that doesn't work either. So it's kind of like in my head, I always imagine like 50% of JavaScript is just JavaScript, and the other half is specific to where it's being used. And in that way, it's a little strange because as developers, you could kind of like you've already half learned the JavaScript for the web by language. There's just a whole bunch of stuff like documents and get element by IDs and add event listeners that has nothing to do with Node, but is specific to web. But yeah, that's basically JavaScript for the web. It's a bit more verbose language. The reason that Node.js was basically invented and the reason it's been so popularized is because most websites are still built in JavaScript today. Like it's been an extremely lasting 30-year project of JavaScript in the web browser. But a lot of people figured out that, hey, if you actually start then writing your servers in JavaScript, you can create these very tight-knit common knowledge teams where people can write both a back-end and a front-end in JavaScript, which is why to this day it is by far the most popular tool for basically app building, like product building out in the real world, because everything has to be built in JavaScript on the web anyway, basically, unless you're building a pure native app, and therefore it's like, isn't it great if our server can run on it? A really good example for you, right, is JavaScript ATO tax calculator. We kind of do this, I don't know if it'll be easy, but to calculate tax in Australia, I'm not sure if they have a nice little function for me. I don't know. Let's just imagine for a second I have a little function called like calculate tax, and I put in my income into the function, right? And inside that, what I say is, well, hey, if your income is less than, I don't know what it is, they changed it on July 1, like 18,000, you return 0 for your tax. Else, if your income is like less than, it's like 40-ish thousand, then you return like, it's like 3,000 plus income. It's some formula, right? Like a bunch of you have probably thought about tax at one point or another. It's something roundabout like this, and then there's like another few else ifs for the different brackets, like that. And the cool thing about writing front ends and back ends in JavaScript is what we actually do at work, and a lot of companies will do this, is there'll be this nice little function here that works in both the web browser and inside Node.js. So what we do is we actually can import this function, we like export, right? Like you know all about exports. We can essentially export this into both our front end and our back end in one common source of truth. And you can do this as well with like variables. Like we have things like, say, const color homepage, or like something, color's maybe not the best example, like, cost of sign up might be like $10 or like, 1,000 cents. Something like that. And you can import that into both the front end and the back end, and therefore you have one source of truth and it's all based on the same language. So that's essentially how Node.js has like kicked up a lot, because we've been building stuff in like since before I guess last 25 years, JavaScript's been ruling all of this stuff. So it's been front ends since you've been a kid. Any website you've been on's all been like JavaScript. It's only recently Node.js has just picked up. It's like Canva used Node.js, like they're only 12 years old as a company. They kind of came in at the time it was starting to pick up a little bit. They wouldn't just use that strictly, but that's why it's a big topic. And that's also where your current knowledge comes into things as well. Yeah, any other questions? Yep.
Can TypeScript work with this front-end JavaScript, or is it just like this front-end?
That's an excellent question. Can TypeScript work with the front end? So web browsers do not understand TypeScript. That's the really blunt answer. The complicated answer is that a lot of modern web, like the one you see on the course website, what it's actually done, and it's just a lengthy conversation, but you basically write JavaScript in these languages like React, Angular, Vue that you might have heard about, and it looks and feels like you're writing JavaScript for the web, but it's actually like it's a Node.js environment, and you can use TypeScript for those. But what happens is that when you compile those, it actually does all the TypeScript checks, and then it outputs JavaScript that runs in the web. So I don't know if Yuchao went through it with you. Did she go through how like the TSC command actually outputs JavaScript at all? Okay. Yeah. So it's basically like you can write front ends in TypeScript, but you're not actually writing in straight JavaScript. You're writing in something that will output straight JavaScript. And a good example for that is that the course website, it's not written in JavaScript, in TypeScript, but it could be. But you'll see, like when I look at this, when I look at the source code for the website here, this is the source code for the website, and it includes a bunch of JavaScript that's been imported, like in this file here, right? But like I didn't write this code at all or anything close to it. I wrote something that like looked really similar to like this. Which will look, again, it looks like, that's not, let me find something like a bit more. Yeah, I would have written code that looks quite similar to this, which, the layers of this get really annoying, which looks a little bit like web stuff and looks a little bit like the Node stuff you've been writing. That's like a front end. And what it does is it outputs that JavaScript that you see here. It compiles into that, basically. And you can write this in TypeScript. But the web browser couldn't understand this. If you tried to pass it in, it doesn't get it at all. So if this makes sense, like not many people these days are out there building websites like this here, right? Just like most people aren't using C. But we teach it, and it's important to understand, because if you don't understand how things work, it makes it really hard for you to basically debug and make sense of things. Like with JavaScript that things are being mallocked somewhere. You know that there's memory that needs to be cleaned up, So when you read about JavaScript, or you were to try and make sense of it, or JavaScript has types, right? When I say things like, an int gets promoted to a string kind of thing, you'll kind of get it because you did C in first year, like this year. Last term? How many did 1511 last term? Okay. You understand that like there's types and each type has a different amount of memory, right? Like you can make sense of that and it helps develop your understanding. It's the same kind of thing. Like basically no one is probably writing actual web pages like this anymore. There'd be a few specific instances. But if you don't understand it, it makes it really hard to know what the hell's going on with stuff like this because it's just abstract otherwise. Also, there are probably people out there who write web pages like this because you asked me about Squarespace and Wix before, right? Funnily enough, a lot of the frameworks we use to build websites, they're a lot like the Squarespace and Wix for developers where they make building stuff really quick, but if you're trying to build something really niche, they have a lot of bloat in them because they're trying to just guess what you want something to look like. So they include a lot of crap along with it, that can slow things down. So I don't know. I haven't actually asked anyone about this. I want to get around to it, but I would strongly have a guess. Who's used Canva before? A bunch of you, right? I would strongly have a guess that there'd be some stuff at Canva where people have like tried to write some really raw JavaScript in it because any application like Canva, if not this, something else, it needs to be so performant because there's just so much going on the page. Like there's so many elements being dragged and moved that sometimes you actually need to understand this deeper tech because you're going to have to write something close to it. But yeah, that was a bit of a long wind on TypeScript for sure. Any other questions? Okay, well, just a quick recap. I've shown you the 3 basic technologies that want to run in a web browser. Web browser compiles those 3 things and it produces stuff. I haven't shown you enough that would, there's tons I haven't shown you, but everything that you haven't seen, nearly everything, is just an expansion of that really basic stuff we talked about today. The purpose of today is not to really make you feel like you could go and make a web page. It's more like to make you feel like you know what the stuff is that relates to a web page such that if you wanted to teach yourself, you'd at least be grounded with it, if that makes sense. Like you could go away and be like, oh, I'm going to go learn HTML, CSS. You don't feel like you even know it today because I just showed you a few random things, but at least you know what it looks like and you know the scope of it and it doesn't feel like this kind of unbounded, complicated problem. But again, I will post up a forum link. I knew none of you were going to give me any interesting questions today and we just awkwardly end early. So I'm going to post a forum link up. You can share on anything you want. Ask any question. Be like, how does this website work? Can we have a look at that? Like the TypeScript thing. Whatever it is, I will run through it on Wednesday and we'll just go deeper on it. And it's online anyway, so you can watch it later. I know a lot of you aren't going to tune in on Wednesday because Wednesday afternoon you'll probably start to be crunching a bit with iteration 3. But maybe you want the background noise or maybe you'll watch it a few days later. There is actually one little question that got asked here that I'm just going to answer. Ghost of Blade says, little off topic, but is there a large difference between Java and JavaScript? I've seen them both and they look quite similar, but I don't know what Java is used for. Yeah, so the short answer there is yes, they're significantly different. They basically have no overlap at all. I can't remember off the top of my head the kind of etymology of JavaScript, the name. But I would look at JavaScript and Java as different as Python and Java. I can't even think of anything that remotely I'm sure there's I'm sure there's similar things to it, but there's similar things between lots of languages out there. Nothing that I would ever be like if you knew Java, I don't think it gives you any head start on JavaScript and vice versa, if that makes sense. So quite different. Cool. Anyway, let's wrap that up there for now. Hope that was interesting. Hope you enjoyed the art that we created together. That wasn't it. I want to find the art we made. It's in the other browser, isn't it? Yep. I will memorialize this forever and think of you every time I see it. Yeah. Cool. Thanks, everyone. I know I said last time I was here that it's the last time I saw you, but I got the timetable wrong. So this is actually the last time I'll see you this term. And good luck with iteration 3 and otherwise.